Okay, so the circuit board showed up today for the binaryEnigma, and I was able to get one put together. So I'm going to kind of do a quick demo of how this works. Basically, this is a project that said, how can I make the most minimalist Enigma machine that's a fully functioning M4 model with a plug board that could fit in someone's hand. Okay, so this is a small little board. We've got a little strap for it here, so it's basically a little handheld board. Now flip it over to the back. This actually operates on just a standard CR2032 lithium battery and has just a few components, just enough to make it work and provide a reasonable level of static protection. So you can see there's a key on the back of this. Let me zoom into that a little bit. This actually shows each letter along with its binary pattern, and there's nothing mysterious here. A is 1, B is 2, C is 3, and so on. So if you're familiar with binary at all, you can see that basically each letter all the way up to Z, which is 26, has a pattern of in this case it's dashes for off or an asterisk for on. On the front of the board, you'll see there's 5 LEDs, and so this really represents whether the LEDs are on or off. So now there are a few command instructions here. See if that zooms in enough. Configuration is something you can choose to do if you turn the first 3 LEDs on. Backspace lets you roll back the indicator 1, that's 4, and then finally if you want to turn it off, you can just set all 5 on and execute that, and it will turn off. Now if you wait, it'll also turn itself off. One of the things that I really wanted to do with this project was make it very power conscious. Okay, I mean usually you're not going to see a lithium coin cell being used with LEDs because LEDs are so power hungry, but these LEDs actually happen to be some King Bright Heli 2 very ultra bright and low current LEDs. So as it turned out, the battery should actually provide over 200 hours of use, so it shouldn't be a problem. So I'm going to go ahead and actually let's talk about these buttons as well. So because this is binary, you basically have 5 buttons across the top, and you have the first 5 buttons across the bottom all represent a binary character. Okay, so if you want the letter A, you just want to press this 0 and this light will light up, and then you will have the letter A. So everything that you enter has to be entered in binary, and then every kind of output, like when you encipher a letter, it's going to show you the result of that encryption in binary as well. And that's why that key is on the back, but it's the kind of thing that once you start doing it a little bit, you'll learn the letters. So there is a 6th button off to the right here, and it has EXE for execute. So the general way to use this is to enter what you want to enter on the 5 buttons to the left, and then press execute to execute that. So the first thing I'm going to do is throw the battery in, and there's one sequence that you're going to see during power up that you don't see anywhere else, and it's going to basically turn all 5 LEDs on as a test, and then it's going to show you the version, the firmware version. In this case it's just a 1, so that's going to be displayed in binary. You're only going to see the 0 light up. So if you watch, you're going to see all 5 come on, then 0 will come on, and then 0 will appear to dim down, and we'll talk about why it does that in a second. But here goes the battery. So there's your 5, there's your version, and there's your dim down. Okay, so the display will actually show the rightmost rotor indicator value on it when none of the buttons are pressed. Okay, so in this case, and it will do that with a dim light. So if I press button 4, watch what happens. Button 4 or light 4 comes on bright to tell you you've selected button 4, which is the 1, 2, 4, 8, 16 value. Okay, so if I was going for the letter P, that's 16. So this would be if I wanted to enter the letter P. Okay, now the minute I turn this off, notice that it's going to go back to showing this indicator value dimly. Now if I turn this one on, you see it goes to bright or it goes to dim. So anytime you enter a pattern, it lets you enter whatever pattern you want, and you can press these concurrently. They're all independently debounced, so you can press multiple buttons all at the same time, and it'll register that without any problem. You don't have to hit them in any kind of sequence. So in this case, I've lit all 5 up, and if you remember from the key on the back, all 5 up is power off. So if I hit execute right now, it's going to shut off. Okay, so now it's turned off. It'll wait for any button to turn it on. Go ahead and turn it on again, and it's still right back to that indicator value showing an A. So what we know is that, and if you kind of have to understand how the Enigma works to understand this demo, what we know is that the rightmost rotor is on an A. Okay, so if I want, there's a this is currently, when you turn it on, initialized to a default configuration, which is a M4 with no plugboard cables, and the wheels are set to beta and 1, 2, 3, and the ring setting is all A's and the indicator setting is all A's. So there is a setting, if you start entering letters, you'll get a pattern. In this case, if I enter A, I'm going to get B, D, Z, G, O. Those are the encrypted letters. Now, if you know about the Enigma, it's a reciprocal machine. So if you enter B, D, Z, G, O, it would output A. So let's go ahead and test that out. I'm going to go ahead and enter a letter A, which is just that, and I'm going to hold down the execute button. Okay, now you can see that it's now displaying just the bit 1 value, which we know is 2. So this is the second letter of the alphabet, which is B. Okay, when I let up, now it goes back to the indicator, and you'll notice now that it dimmed down, but we're not looking at LED 0, which is an A. We're now looking at LED 1 only lit, which is a B. So the indicator also moved from A to B. Okay, so I'm going to go ahead and enter another A. Now this time when I hit execute, it does something different. Now it's basically outputting letter 4, which is a D. Okay, so remember I said the sequence was B, D, Z, G, O. So we're now looking at the D. Okay, so if I let up, now you'll notice that you've got both 1 and 0 lit dimly. That's 3 for a C. So the indicator value, the rightmost indicator rotor value, has changed to a C. So I'm going to go ahead and do it again. Enter an A. And now we've got this pattern. Now if you look on the back of it, you're going to find that this pattern is Z. Okay, so we're going to go ahead and let up, enter another A, and we get the pattern G, and then finally we get the pattern O. Okay, and you'll notice now that the indicator value is got 1 plus 2 plus 4. It's really just 2 plus 4, which is 6. Okay, so you are looking at a value. Hold on a second. Looking at a value for F. Okay, so if I want to, one of the other features that it has is the ability to roll the indicator back. If you want to roll the indicator back, like let's say I made a mistake, that last letter I entered was an A, but I really wanted to enter a Q or something different, there is a backspace function. If you turn on the first 4 and hold the button down, you'll actually see it roll the indicator back. There's 4, 3, 2, 1, which I should be saying the letters, you know, D, C, B, A and such, but now if you keep going too far, you'll notice it can't roll before A. The reason why is that the M4 is a lever-based machine. What that means is that there's no way to absolutely know what came before on the indicator. Okay, there's multiple indicator values that can roll to the same thing because of the lever mechanism. So what this binary Enigma does is it keeps track of the characters you enter, and it keeps track of the last 50 or so indicator values, allowing you to backspace. But once you get to the front of that rotor history, you can't backspace any further, which is why I can't go back any further than this. So this leaves the indicator value with A. But if I now turn these off and I enter an A again, in fact, you know, let's do this other thing. We're going to enter B, D, Z, G, O. Okay, so if I enter a B, it's going to come out with an A, and there it is. Then I enter a D, it's going to come out with an A. And then if I enter a Z, which is boom, 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 outputs A. Then if I enter a G, outputs an A. And then finally if I enter an O, outputs an A. So there we just basically did the reciprocal. We encrypted and then we decrypted. So, and again, I'm going to go ahead and roll the indicator back just because go back all the way to the A. So that is how the operation of it works, and it's pretty easy. the next thing that you really need to know how to do is how to configure it. So configuration requires, now by the way, the one thing you might have noticed too is that the backspace doesn't clear off after you execute, whereas every other thing you do, if I enter, you know, a C and tell it to encrypt, as soon as I let up, it forgot my C, okay, because it knows I want to enter a new letter. So the only thing that will, backspace will remember that because it knows you might want to backspace more than one time. So in this case, I'm going to backspace back to A. So I'm going to go ahead and go into configuration, okay. The thing about configuration, and then really the thing about the binaryEnigma, is that you only have 5 LEDs to and 6 buttons to configure an entire machine. So you have to remember where you are, and that's one of the reasons for the dim light. The dim light lets you know you are out in the main machine mode and you're ready to encrypt or decrypt. Now, if you look on the bottom, we have some labels on these buttons like escape, first, next, previous, last. Those come into play when you're in configuration. So we're going to go into configuration now, and to get into configuration, you use the first 3 and you hit execute. Now, at first it looks much like the other display, but again, you have to remember where you are. Now, this is not a dim, it's a bright. So that's one thing that'll help you. Another thing that'll help you is if I start going previous and next, you'll see that this moves differently. This kind of moves like a menu. The thing is that there's labels on the top that show what each thing is. Like right now, it's an indicator. If I go left one, both lights are lit up. That's for ring settings. If I go left again, rotor, that's for rotor settings, plug board settings, reflector settings. Hope my finger's not in the way enough here. Init will initialize the machine. Load lets you load one of 18 configurations that you can save to EEPROM. Save lets you save a machine, and erase will let you erase a machine. So just for curiosity, let's go and take a look at all 4 indicator values. You know, the M4 is a 4-rotor machine, though the leftmost rotor is a thin rotor that doesn't move during encipherment. It lets you set all 4. So what I'm going to do, instead of just nexting through this, if you hit last, it'll jump right to the end. It's likewise, if you hit first, it'll jump all the way to erase. So I'm selecting indicator, and I'm going to go ahead and hit enter or execute on that. And you'll notice you get a flash, but it takes you right back to almost the same thing. Now, again, you have to remember where you are in the menu. We're not actually in the main menu of configuration anymore. We're now in the indicator menu. Okay, and if you notice, if I do next and previous, it doesn't do the half steps anymore. It only has 4 options here, which are for the 4 rotors. Okay, this is your leftmost rotor, the thin one. Then this is what they traditionally call, I think, rotor 1, then 2, then 3, finally your rightmost rotor. So now this right one, by the way, is the same one you see that is dim. If I hit enter to go into it, it's an A, which we already know, because if you're in the main menu, it shows this one dimly. Now if I leave and I go to the second one, it's also going to be an A, third one's going to be an A, and the fourth one is also going to be an A. So if you wanted to change this to something different, like B, 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 now all 4 rotors, all 4 indicators are set to a B. Okay, and you can go into each one and check it if you want to double check it. Okay, so now that I have them all set, if I hit the escape key once, I'm going to be back at the main menu. So if I go left here, you'll see that I can go to the ring settings or the rotor settings, and let's go look at rotor settings again. When I hit enter, it's going to, or execute, it's going to take me to that typical 4 menu. So I can look at what rotor is set for each one. So let's go ahead and look at the leftmost rotor, and this rotor is kind of a goofy one. You only have 2 options. Your option is beta or gamma. So beta, B, represented with a 2, gamma, G, represented with 7, because that's their values. So you have, if you hit previous or first, it takes you to beta. If you hit next or last, it takes you to gamma. So in this case, it was set to beta. We'll just leave it there. Now if we go look at the other rotors, the next one is set to rotor 1. The next one is set to rotor 2, and the other one is set to rotor 3. And you can actually go all the way up to 8. There's 1 through 8 is the number of rotors that you can do. So we'll set this back to What did I do? I think, oh, I'm up on 8. I'm going to go back to rotor 3. So there's rotor 2, rotor 1, and rotor beta. Okay, so that's how you set the rotors. Now, the reflector, we'll pop over there and set that real quick. The reflector has two options. There's a B reflector and a C reflector. So again, your options are B and C. The plug board is the toughest one of these things to configure, because essentially, I'm going to go into it now, essentially you have up to 13 pairs of cables, 13 cables that can connect to 2 letters each. Okay, so the way that this has been implemented is that the 4 left LEDs can be thought of as the cable number, and this rightmost one can be thought of as either the left side of the cable or the right side of the cable. So you don't have to think of it that way, but that's probably the easiest way to think of it. So in this case, I'm on cable 1, and then I'm just going to assume that when this is out that it's the left side. Now if I advance it 1, that'd be the right side. And if I advance it again, now I'm on cable 2's left side, cable 2's right side, so on and so on. So let me go into cable 1 left side. As soon as I hit enter, all the lights go out. Now there's not many places in configuration where there's no lights on. Okay, in this case, essentially the plug board, the cable is unplugged. If there's no light set, it's unplugged. So if I want to plug it into C, I just light up the C. If I want to plug into G, I can light up the code for G. In fact, we'll just go with G. Okay, so I'm going to pick G and hit enter to leave that, and it's going to take me right back to cable 1 left side. Now if I go to the next cable 1 to the right side, and I go in that, and I'm going to set that to an A. Okay, so basically what I have is a cable plugged into G and A, and if you know about the plug board, it swaps letters G and A. So if I go back to cable 1 left side, set to G. If I go to the cable 1 right side, set to A. So now if I type a G in, it's going to give an A. If I type an A in, it's going to give a G. So that's, and of course you have up to 13 of these that you can do. In fact, we'll go ahead and scroll through them. There is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Final one is 13 with the right cable. So, and again, you can use first and last to hop to those extremes. So that is how the plug board sets. So if I just went into it. So you want, again, with setup, you want to make sure you remember where you are. But if you ever get lost, you can just keep hitting escape, escape until you get to that dim value. Now, there are some menus that you can't hit escape out of because it expects an adequate answer, or it expects a value that's valid. For example, if you go into the indicator and you turn all of the LEDs off and try to enter that, that's not a valid value for the indicator. So if you enter, nothing's going to happen. It's going to wait for you to enter a valid letter from 1 to 26 before it lets you out. So anytime you're in binary edit mode, which is like if I go into the indicator and I'm changing an indicator, this 4th button is not escape, it's actually bit 4. Okay, so you have to hit enter to leave that, then you can use it as escape. But you can't leave it if you're on some number that's invalid. So you may have to set it to a valid number, then escape out, figure where you are, then go back in and then set it if you've lost your way. So the other settings are pretty easy on here. If I go to, I'm actually in edit mode now, so I'm going to go into configuration. Then I'm going to go over here to init. As soon as I hit enter on init, it is going to blow away every setting that I just made and set it right back to that factory, what I call a factory configuration. You see it flashes all 5 and then it returns the configuration menu. So now those plug board entries we put in there for swapping G and A are no longer. It's right back to a factory config. So if I go over to load and I hit the enter, it's going to load. It's going to ask me which one do I want to load, and there's actually 1 to 18. So if I hit last, it takes me all the way to 18. First is all the way to 1. So you can load or save 1 to 18. You can also erase 1 to 18. So in this case, I'm going to hit execute. It flashes. So it did have a configuration at spot 1. Now if I go to spot 2 and hit that, notice it doesn't flash. That's because there's no machine saved at spot 2 currently. And if I wanted to make it so that spot 1 was also empty, I could just go to the erase and then erase spot 1. But it took a while to enter that one, so I don't want to do that. So save works just like load. You basically go to, I'm going to hit escape. I'm going to go to save, which is both of those lights lit up, and I'm going to hit enter, and now I can pick 1 to 18. So let's say I'm going to save it to 2. Now it's saved. Now if I back out and I go back to load, and I try to load 2, I'm not going to get that little single light where it doesn't do anything. I'm going to get the full 5 lights saying, okay, it loaded a configuration for me. So if I back out of this and I back out of the menu, now I'm back to where it's ready to let me encipher, and you can see that it's got the first 2 LEDs on. That's the letter X. So we can pretty much figure out that the rightmost indicator is X. Let's go ahead and just go back into configuration and see what the other indicator values are. So I'm going to go into configuration. I'm going to go into indicator. I'm going to go to the very leftmost indicator, and it looks like we've got a P. So the left one is a P. The next one is a K. The third one is a W. And the final one is an X, like we spoke about a moment ago. So that's pretty much how you use the binaryEnigma. Go ahead and show, I'm going to turn it off. It'll time out after 5 minutes, so it won't use a whole lot of power if you just leave it alone and let it. I need to get out of this menu though. See, so now we have the perfect example of what I said earlier. I am hitting execute on this, but it's not turning off, so that tells me I'm somewhere in configuration. Okay, so I'm just going to select something. Yeah, I was actually in there changing one of the indicator values. Okay, so if I say, okay, I've messed up that machine, I can just go back to load, and I can go all the way back to the main menu. So I'm at the main menu, gonna go to load, and I'm gonna load machine 1. So now I know where I'm at again. Okay, so that is one of the things you're gonna have to keep track of. When you have so few LEDs to indicate where you are, you definitely have to keep track of where you are. So now if I go to turn it off, off it goes. So let's flip this around. I'll just kind of cover how this works. Basically, we've got a 3-volt CR2032 lithium battery powering it. There is a, on the right next to that, you can see there is a, on the bottom is a little ESD protection diode. Above that is a tiny fuse. To the right of that is a capacitor, and to the right of that is the brains of this outfit, which is a Atmel Tiny 84A microcontroller, and then there is a little resistor net array that limits the power going to the LEDs to the right amount. So that is basically the whole project. You have, and my finger hit a button which woke it back up. Then you've got the buttons on the bottom. Now, one of the things I talked about earlier is that you don't have to do 1, 2 like this. You can hit them both at the same time. You can hit 3 buttons at the same time. In fact, you can hit them all at the same time, and they will all register the bump. Each one is independently bounced, so you don't have to do 1, 2, 3. You could actually just do all 3 if you want to do it. So hopefully that is a pretty good video on how to use it. So if you have any questions, send me an email, support@sadevelopment.com. Have a great day.